Hello everyone, welcome to the session 4D on machine learning. So let me introduce you to the session chair, Dr. Randil Pushpananda. He is a senior lecturer at University of Colombo School of Computing. He obtained his BSc in Engineering Physics Honours from Faculty of Science, University of Colombo, Master of Computer Science and PhD in Computer Science degrees from University of Colombo School of Computing. His research interests are in natural language processing, especially in machine translation, speech processing, and machine learning. Currently, he leads the Language Technology Research Laboratory at University of Colombo School of Computing. Dr. Randil, I invite you to lead the session.
Okay, thank you, Kavinder. So today in this session, actually we have 5 interesting poster presentations. Our first presenter is Sumit Gamage. I think he's in it's already this session, right? So paper ID 38.
Good afternoon, Dr. Andil. I am available. Yes, we can proceed.
Thank you. Okay, our first presenter is Sumit Gamage, paper ID 38. He's Sumit Gamage is the Managing Director of ASA IT Solutions and Director CTO of 60 Plus International Private Limited. And he was one of the founders and directors of Omobio Private Limited, one of the leading telco solution development company, not only in Sri Lanka, but also globally. And he has more than 18 years of experience in software solution industry, in addition to serving as a lecturer at the University of Moratuwa. And Sumit recognized as an emerging entrepreneur by the Computer Science Engineering Society of University of Moratuwa in 2016. He has been engaged in solution development for mining industry from 2017 and won the Iswabmani Award in 2019 for his Valley Tota app. His Pro solution was recognized, received the first place in government citizen engagement category in Iswabmani 2020 and nominated to World Summit Award in addition for selection for winning circle of NBQSA. So is this title of this presentation is improving the government revenue in mining industry with digitization. So first we'll go through the presentation. Yes, so you can play the presentation.
Hello.
So you are presenting that, not recorded one, right? Okay.
Either one is all right with me. I have already shared you the recorded video. If you are playing that, that will be best because that has a sort of a quick summarized view of the solution. So I can start my presentation from there and go to the Q&A.
Yes, that's fine. So Kavinda, can we play this?
Roshan?
Yes, Kavinda, I will play that.
Sri Lanka, the pearl of the Indian Ocean. It is an island rich in mineral resources. Mining mineral, which brings a large amount of foreign exchange to the country, takes place in many parts of the island. Those minerals are used for
If there is no difference between playing from my side, if you want, I can share my screen and play it.
Yes, I think then if you can share, then I think it's better.
Yeah.
Yes. But we cannot hear. I can see.
Can't you see it?
No. We can see, but cannot hear. There's no sound.
All right.
Roshan, do you know how to enable that?
Yes, sir.
Yes, sir.
When you are sharing the screen, you have to enable the allow the sound from the computer to be there. There is a radio button in the left side corner.
Okay, let me see.
Because you have to unshare this.
Okay.
Okay, now when you're sharing, there will be a dialog box like radio button thing that is asked for you to permission to share.
Right.
Okay,
Okay.
you have to click.
Got it. Thanks. Let me try it now.
Sri Lanka, the pearl of the Indian Ocean. It is an island rich in mineral resources. Mining mineral, which brings a large amount of foreign exchange to the country, takes place in many parts of the island. Those minerals are used for local constructions in addition to export into foreign countries. All the operations of legal mining are monitored and supervised by the Geological Survey and Mines Bureau. But the unauthorized miners have made this process difficult to the officials. This illegal mining and transportation have caused a number of problems, including increase in environmental damage, the rapid closure of mineral deposits, decline in government revenues due to the loss of royalty, environmentalists being frequently accusing GSMB and the government. It is obvious that there are many reasons to increase illegal mining, such as the delay in the issuing of transport licenses, lack of transparency, complexity of the process that applicants has to follow. Pro is a solution proposed by the Geological Survey and Mines Bureau in collaboration with Sri Lanka Telecom to solve these problems. This fully digitized solution includes the ability to access using a smartphone application, a web portal, or SMS service. Additionally, an optional printed copies can be taken using the portal Bluetooth printer or standard printer. In addition, the mobile app is designed to be usable even in the absence of data and telephone connections. Operations during the absence of telephone connection are automatically updated to the central system once the connection is restored. Through this, the Geological Survey and Mines Bureau aims to serve mining license holders, hardware and other mineral trading license holders, the general public, environmentalists, the police officers, the construction industry, other governmental and non-governmental organizations, and officials and administration of the GSMB. Mining license holders can obtain all the information about their license and update their daily mining and transportation details in addition to viewing their operational history. The general public and the police can simply check the validity of the mineral load by simply giving the vehicle number. However, only the police can obtain a detailed report of the transport safeguarding the mineral transporter. Also, if the mineral is illegal, anyone can report to the Geological Survey and Mines Bureau directly through the application. The core functionalities of the application are facilitated through SMS for all the parties mentioned above. Let's play our role in protecting the Mother Nature.
All right. Thanks for your time taken on the video. Let me go through 2 slides only to explain you how this has been served the country. So in the country, there is a mafia for sand. The transport license costs just only 106 rupees, sell out at 3,000 rupees in the market. Due to this, the government, the new president came in December 4th, cancelled the transport license. With it, of course, increase the illegal sand mining, and out of GSMB officers, about 60% became idle. So they wanted a digitized solution. So that is what you saw in the video, but out of that, what we gain is presented in this slide in summary. As you can see, the charge per cube, it was 106 rupees per lorry of 3 cubes. That means 35 rupees per cube. And the cost per cube has been estimated, even though they charge at 35, it was about 55 rupees. So with Pro or this digitized solution, we managed to bring down the cost of service to 17 rupees per cube. In other words, the government managed to, by deploying this island-wide, the government can save 125 billion rupees per year, which is going about 58 million out of the country. There is a potential of in the country through GSMB, even the GSMB is the regulatory authority in the country, they have track of only 50% of the real sand usage, or the real, especially the real sand usage. The rest is coming in illegal means. By bringing this into the track, we will be able to save, earn 2.4 billion rupees per year as royalty. So this is the overview of the solution. I'm not going to touch on this because that was what explained in the video. So how the big data analytics or the machine learning is to come here. So with this implementation, we have already proven with the trial in the largest river sand mining site, that is in Manampitiya, we can operate it digitally, as well as we will be able to get the general public to crowdsource in order to restrict the illegal mining in the country. So with this, we have a big data to be analyzed and to be deployed in the, after deploying it island-wide. With the current data, we have done the basic analytics, so we are in the phase of rolling it out to the entire country. So there are, with the new government change and all these things, there is a delay in the thing. But of course, we have done our initial trial on this. So this is a sort of a high-level diagram where we apply our digitization or the big data mining applied in the entire roadmap of the big data mining industry. So that is what I want to highlight. So without continuing rest of the slides, I might be able to open the ground for the question, and based on that we will be able to proceed to the rest. So that's what we have done and what we have achieved so far. Over to you, the audience or the controlling team.
Okay, thank you, Sumit. So now audience can ask questions if you have any. Any questions from the audience? Okay, I have one question that is actually in your paper you have mentioned that this system can work in offline mode also, right? So
Yes,
they are actually so how do you how do you handle that process?
It's like this. We are talking about mobile application. The mobile application, when we are talking about these remote areas where the sand is extracted, you will not have even the data connectivity or else even the mobile connectivity. So what we have done is we have mobile application working on local storage. In case of the connectivity is not available, it will store that transaction data in the local storage. As soon as it identifies the data connectivity comes up, even though they are mining in a remote area, they will come to their home or to the town. At that time, it will synchronize with the central cloud servers which we have deployed in Sri Lanka Telecom. So that is how it handles the offline data or when the application work offline.
And so the other question is so if so until it enables that if we get some internet then only they can this is synchronizing. Otherwise then the police and also the other people, how do they know that this happening like that? So
Yeah.
how?
For that we have a backup plan, backup option for them, where we have the printed copy of the receipt. We have a printed receipt where they will be able to take it with their hand, as well as we have provided the option, if the data connectivity is only the problem, but if they have the mobile connectivity, they have the mechanism of doing the transaction via SMS. So the one option, the second alternative is to go for SMS. If they have, then of course the entire transaction is recorded in the central system. If they don't have even the mobile connectivity, then they can go for the printed copy, where we provide the portable printer, where they will be able to print the receipt and give. That has its unique number, which can be cross-checked by the police and let it go. So this two options are available as a backup in order to make sure the operation is not operation is not make any problem. They can do it without a problem. So we have the two backup options to run that.
Okay, thank you very much. So we'll move to the next presentation. So the next presentation is the paper ID is 114. So paper title is image processing application for real-time defogging, and this is going to be presented by Heshan Indikatia, and Heshan Indikatia is fourth year undergraduate at Sri Lanka Institute of Information Technology, and he is following the BSc Honours degree in Information Technology degree program, specializing in interactive media. So I will invite Indikatia to do his presentation. So I think he's looking to this.
Can you play?
Okay. Yes, we'll play the video. Right. Okay.
Okay.
Indikatia, fourth year student at SLIIT. I am here to give you a small explanation on our fourth year research project. The project we are implementing is a defogging system for vehicles. Our team supervisor is Mr. Ishara Gamage. Co-supervisor is Mr. Tusita Anjana Tilakaratna. And I am the group leader, and my members are J.M. Thomas and K.M. R.A. Kulasekara. So an introduction to our system. So one of the most dangerous weather types when driving is fog. These days, many vehicles have fog lamps and windscreen defoggers, but those are not very helpful. So our system that we have developed is called defog. Defog is a system that using the dash cam, a thermal sensor and a LiDAR sensor will give the driver a clear real-time video of the objects ahead. So the research problem we faced was fog and haze reduces visibility, limits distinction, and causes many fatal accidents every year. So fog is produced by the deferment of very fine vapor drips in the air. When these drips are light, it disperses and results in a loss of contrast and a thick white background. As a result, vehicle drivers cannot see far ahead, and vehicle accidents become even large amount of possibility than normal. So there are three ways fog affects these drivers. Due to the lower contrast, it distorts your perception of speed, and the drivers will have a hard time recognizing between living things and non-living things. Because of this blurry view, drivers can't estimate the distance between the objects ahead. So our main objective is to implement a real-time defogging system to give a clear view to the driver when driving in unclear weather situations to reduce vehicle accidents. Also to improve visibility and give an assist to the driver with object detection and distance measuring. The methodology we followed. First, we take the dark channel as a priority, and then we minimize the atmospheric light. Then we re-blur the signal from the camera and determine twice with Gaussian kernels. Then we fix the local blur size of the signal. That signal is then convolved with a Gaussian kernel with different standard changes leading to two signals. To make local blur independent of amplitude, the ratio is computed. Then we apply a maximum filter to the signals to calculate the maximum ratio. Normally, the smallest blur size locally is calculated around the edge. Then we apply an adaptive medium filtering. So to segregate the distance and the objects, we first convert the surroundings into a coordinate plane. Next, the moving objects will be segregated from the background. Then a combination of mobile net and solid-state detection algorithms are used to identify vehicles or moving objects across the frames using deep learning neural networks. Each tracked object is then given an ID using the cafe model algorithm. The accuracy of the object also is visible with the distance. Then the distance is calculated using the speed of light rays reflected back into the LiDAR sensor. Finally, its coordinate plane is integrated into the dehazed video stream with the detected objects. So summary to our system. So we are using the dash cam and getting the real-time video, and then we are dehazing the real-time video to display a clear video, and then we are using deep learning algorithms to to identify the objects ahead and to highlight them with a square, and in that square we are using LiDAR sensors and the thermal sensors, and we are displaying the distance and the object name of the object. Thank you.
Okay, thank you, Heshan. So, yes, so audience can ask, if you have questions, so you can ask from Heshan.
Hello.
Yes.
I am Tivan Kanwas. So can I ask a question from Indicator?
Yes, sure.
Indicator, I want to know how do you choose living objects and non-living objects?
Yeah, from the using of HOG feature extraction, we are detecting objects in front of the vehicle. From the thermal camera, we are getting heat signals from the vehicle, the things in front of the vehicle. And using of algorithms like mobile net and solid state detection, we are detecting the objects in front of the vehicle as living things or non-living things.
Okay, thank you.
Any other questions? So I have one question. So how did you test this system?
We actually the proper way in testing this system is going for a area like there is fog like Nuwara or Matale, just like that. But in Colombo, we tested it. We built a smoke using smoke grenades we are imported from eBay. So from those things, we tested this, and we tested what you call the objects in front of the vehicle is from there is smoke, and we tested some living things just like our humans, and solid state things just like rocks. So it detects, we tested like that.
And the other thing is, why did you use deep learning techniques for this?
We used deep learning things because we have to check this is a living thing or non-living thing, and we have to use those feature extraction technologies. So that's why we used deep learning things.
So how much data that you have used for this, for the training?
Sorry?
How much data that you have collected to train?
Yeah, we used a library called YOLO library. So there are plenty of data they used, and we got the help from that.
For that, how did you divide that training and testing, and then how is that? In your paper, actually, you haven't mentioned those, right? So how did you divide those the data?
Can I couldn't get it.
No, I mean, you have mentioned that you have extracted the data from YOLO, and then do you know how much data that you have used for this, and how did you divide that into training and testing? So
Yeah, actually, from YOLO, there are plenty of things, plenty of data they used, and we got the help from there. I don't know actually how much data they used to get those things, but we use that. And
when you are use deep learning, when you're using deep learning techniques,
yeah,
it needs a lot of data, right? Large number of data sets you need, right? So therefore, so you need to know those information, right? So otherwise you can use, and you don't need to use deep learning techniques, right?
Yeah.
Okay. Any questions?
Yes, Dr. Kandil, I have a small question.
Yes. Sure.
So, what is the distance range that you all are working on? Is there a limitation? The distance range that you all are working on, for example, in a foggy environment, up to which distance that you can like detect the objects?
For now, we are tested our system in 10-meter distance, but we are planning to get more distance accurate.
Okay, great. Then, how would you show the obstacle information to the driver? So, is it a different display?
Yeah, it's from a different display, just like we are getting the information from dash cam, and there is another screen fixed inside the dashboard. So from there we can show the objects just like from a square, and the distance are in the screen also.
Okay, that means the driver in a foggy environment should look at another screen to get the objects in front of, right? So it's again maybe risky because so you need to think about how would you like come up with a better solution so that to minimize the distraction while driving on a foggy environment.
That's the thing we got from our questionnaires. That's the thing.
Yes. Okay, thank you very much.
Okay, thank you.
So any other questions from the audience? Okay, so thank you, Heshan. So now we'll move to the next presentation. So next presentation is next presentation is supermarket retail-based demand and price prediction of vegetables. The paper ID is 126. So presenting author is Hashini Warnakulasuriya. So Hashini is a finally undergraduate student reading a BSc Special Honours degree in Information Technology and at Sri Lanka Institute of Information Technology, and she is currently working as a trainee software engineer at IFS Sri Lanka. So I'll invite Hashin to his presentation. So I think we have the recorded video, right? So.
Hello everyone. Have you ever wondered about the daily vegetable wastage occurs inside a supermarket or even a small grocery shop that's situated on your way home? Have you ever had a doubt on the origin of a vegetable which you have bought from a supermarket? Well, that's where AgroSmart comes in handy. So first of all, let me introduce you our team. Dr. Darshana Kasturiratna is our supervisor. Ms. Thelini Jalak is our co-supervisor. I am Hashini Varnakulasuriya. Janangi Senaratna, Prasangika Piris, Shanley Fernando are my co-authors. Our research problem is based on 4 perspectives: farmer's perspective, retailer's perspective, government perspective, and customer's perspective. When it comes to farmer's perspective, due to lack of predictions of vegetable price and demand, when the market price is below the cost price, farmers let their crops to be rot in the field. In the worst case scenario, when farmers find themselves in financial difficulties, they commit suicide even. On the other hand, due to unpredicted prices and the demand, time to time the supermarket warehouse can be in overstocked and understocked conditions. That put a major impact on the company revenue also. And due to the unpredicted vegetable prices, government can't plan and implement agriculture development programs or stabilize the price and can't take decisions on crop exports and imports. Due to fluctuation of prices, customers can't plan their daily lifestyle. When talking about the research objective, the main objective of this research is to have a better control of minimizing the vegetable wastage and to deliver best quality products to the customers. By predicting the vegetable price and demand, vegetable wastage will be minimum. Best supply selection will let the supermarket select the best supplier, and also the supermarket will receive best quality products. With the help of the tracking system, we can find the origin of the vegetables. So this is our system diagram. It consists of 4 main components: vegetable price prediction, vegetable demand prediction, supplier selection, and tracing vegetables. All these 4 components will be integrated in the system using APIs. When it comes to price prediction, we have used the LSTM model to predict the prices, but we have tried several other models like ARIMA, seasonal ARIMA, auto ARIMA, and XGBoost. But out of them all, LSTM yields better results for long-term modeling, whereas ARIMA yields results in short-term forecasts. So we selected LSTM as our model. So for the demand prediction also, same as in price prediction, we have chosen LSTM model. For the best supplier selection, we have used linear programming and Gurobi optimization solver. To trace origin of vegetables, we have used blockchain for supply chain management, where the customer can input the QR code of the vegetable and trace the source of it without any registration or sign into the system. In the vegetable price and demand coming by comparing the vegetable prices of past farmers, getting the best supplier to rate best quality product for the market and to the origin vegetable which has to the supermarket. And that brings to the end of the presentation. I really appreciate I've had the opportunity to present our work at ICT 2020.
Okay, thank you, Hashini. So I think you are connected to this, right? Hashini, are you there? I think she's in the participant list. Hashini, can you hear me?
Hello, can you hear me now?
Yes.
Sorry, I was muted.
So again, I have one question. So that is again related to the data set. That is so in this research also you have not mentioned how much data that you have used for this and how did you collect that one. So could you please explain that?
Yeah, actually our agreement was with the leading supermarket chain in Sri Lanka, but because of the pandemic situation, we couldn't do site visits. So then we moved to use central bank data. They have collected data from PETA and Dambulla centers.
So how much data actually you got for the?
There were around 45,000 records.
And for the training?
70% for the training and 30% for the testing.
And also you have mentioned that you have used the LSTM, but in your paper actually you have not mentioned what did you get or what are the results that you get from the other approaches, and then why didn't you compare and then do some error analysis, and why didn't you do that kind of thing?
Sorry, I couldn't get you.
So you have mentioned that you have finally decided to use the LSTM model.
Yeah.
And then again you have mentioned you have tried several approaches, so then why didn't you show those results and then compare them?
Yeah, actually we could have used them.
Yes, so that's the important, right? So normally you need to show results that you from all the approaches, and then you need to do an error analysis, and after that then only you can say, because of these reasons you can select the LSTM as the best approach, like that. So rather than just saying this one, so that is you need to remember. And also again, when you are writing a research paper, main thing is you need to have a good idea about the data sets, right? So, and then from that only you can identify the features, and then what are the techniques that you need to use. So those things can be identified from going through the data sets. So those information should be in these papers, right? So any questions from the audience?
Hasini, this is Sumit. It's an interesting thing you have looked for. I'm just wondering whether you show us a diagram of your system, and also, so how practical is it to be used in a real case? I'm personally involved in some of these agro-related stuff where the work you have done or said need to be applied. How well it is ready to try out in real case, I mean with real supplier, with real consumers, with real intermediate supermarket and so on?
Actually, we are thinking of integrating all the 4 components in Docker environment. So the system is not fully implemented anyway, but the supply selection, price prediction, and the demand prediction is integrated. The blockchain part is still need to be inserted to the system.
Okay, thank you.
So any other questions from the audience? Okay, thank you, Ashini. So we'll move to the next presentation. So that is so paper ID is 134. So the paper title is Adjusting the Hard Level on Game by a Prediction for Improving Attraction and Business Value. So the presenting author is Anupam Iranga. So Anupam Iranga is an undergraduate student at Sri Lanka Institute of Information Technology, and is following the BSc Honours in Information Technology and specializing in interactive media degree program. So I'll invite Anupam to his presentation. So I think they do not have the record, so you need to switch on your video, and then you can.
Hello, hear me?
Yes, we can hear you. So you have to share your screen, and then you can start the presentation.
Okay. Okay, can I?
Yes, we can.
Okay. Good evening. In this century, the younger generation move into the PC games. It has become a part of the everyday life. The past studies show the people chose the PC game over physical games due to their busy lifestyle. There are about the 2.2 billion games around the world. First thing, we conduct a survey. We conduct a survey before the commencement of the research with the participation of the young people so scattered throughout the Sri Lanka, and we are able to get a result. First in the 80% game players are male, 70% game players are aged between 16 and 25. 10% responded do not play PC games because they are not interested. 85% of the games like to customize the character. 70 gamers are games are intermediate players. 65 players are say some missions are too easy and boring, like that. Through the collected data, we could see why some is not interested in playing PC games and what are the problems that players face while playing the game. Some problem are encountered the game being too easy and boring to the game beginning to the difficult, which can cause disappointment. We have to identify a research problem based on the above problems. Mainly our research is the how to change the hardness level of the game automatically without player changing the level on his own. This is done based on the player. The other problem is how to make the game more attractive to the player. As a solution, we develop a game that can take the emotion of our of the user and adjust the hardness level of the game. The character of the game is also customized based on the player information such as age, gender, and face shape. Our research objectives: capturing the facial expression and identify the emotion, capturing the heartbeat to identify emotion, obtain haptic feedback to predict predict the player skill level according to the player haptic feedback, detecting the age, gender, and the face shape, provide a unique experience, adjust the level based on the above information and the customization of the character. Mainly, this is our system diagram. The since we cannot make the change to the extinct games, we created a demo game. First thing is the main thing part is the emotion, age, gender, capturing the emotion and the age, gender, and the face shape recognition. The main thing is to identify the emotion and the facial expression in the real time, because we are capturing the what are the player expression of the playing into the game, and we also capturing the age, gender, and the face shape, the player details. Some result of the using the method. Another thing is the haptic feedback. Haptic feedback is a using the keylog. We getting the what is the player skill level. The mainly we are getting the from the keylogger. From keylogger, track the key and the pressing time. Take difference between the two keys pressing time and take a mean value of these differences every 50 seconds. They compare the mean value with the previous pro, beginner, and the intermediate players' mean values. Another thing, just in the hardness level, the output, the result of the emotion take from the both facial expression and the heartbeat are analyzed to get the accurate emotion of the player. To predict we create a new data set. Based on the prediction, the level of the game can be changed. Also, we are the level changing without notifying the some player using the like this graph. We changing the hardness level according to the without notifying. Another thing is player character customization. The output, the result of the age, gender, and face shape we taken and analyzed to predict this created a new data set also. Based on the prediction characteristic of the game character can be changed and predict the emotion. Divided age group 15 and 20. We divide in the age group into the 15, 20, and 20 to 25 likewise. And we are the predict the emotion by the heart rate. The heart rate is measured by a heart rate sensor. Then play emotion predict by the analyzing the heart rate. These are the song. Thank you.
Okay, thank you, Manuka. So I would like to invite the audience to ask questions. Any questions from the audience? Okay, Anupama, so and here you have mentioned that you have used machine learning techniques and AI algorithms to train the model. So, but actually you have not made.
Sorry. Sorry, can I again ask question again?
Sorry.
Sorry. I not clearly say.
So in your paper, actually, you have mentioned that only you have mentioned you have used machine learning techniques and AI algorithms to train the model, but you have not mentioned what are the techniques that you have used actually. So what are the algorithms? So for what purpose or what kind of algorithms that you have used for the training?
Okay, training mainly mainly done in the this part. Mainly we have two different type of models. We are first in the we are training the linear regression supervised method, and another machine is using the CNN using the CNN. Data set convention and chaos library using.
But and again, so according to the paper, you have mentioned that you have developed a game, and then so how did you define the difficulty levels?
Difficulty levels means we are mainly or we are creating the some difficulty levels means we can like example the player running speed we can provide 1 to 10, and difficulty levels mean the 10 is some 10 is a hard level. The difficulty level 10 means the player running speeds so some slow, and difficult level easy we can give it by the player running speed level is 1 likewise.
But when we consider the actual game, so then actually then only you can measure the stress level, and then you can monitor how you have to change that game levels. But here then the issue is you have just only give the range, right? And another thing is so how many players that you have so you have extracted data, right? And then for that you have asked how many users that you used your model, and then how did you extract the information, how much data actually you have gathered.
Okay, mainly main problem is our data set. We can't get this this time actual data because we want to play in this game. Mainly we want actual data. This game, our demo game, playing the another 10 or more game players are playing this game, and we want to collect this data and we want to create it. This time we have created the demo data set. We have included our, we wanted what are the change of the, what are the changes that we want to, and some like emotion is some mainly we capture the first time we capture in the emotion and the sound. Mainly happiness time is we can provide the hard emotion happiness emotion, we can predict the hardest level into the hardness more, increasing the hardness. And he's playing the game, playing time is player also getting the angry, we can hardness level to the easy. Likewise
So
mainly this time
actually you have gathered how much? Do you have any idea about the data set size?
This we created the this mainly data including 7 lakhs data included for the main data set. And mainly we facial can play a facial capture data set also getting the to internet and search, and we have done also still data set, and we create the model and mainly play accuracy can comparing the play emotion level and the play heart rate emotion, and what are the changes, what kind of changes we want to do. Like data set we created the manually.
Okay, any other questions from the audience? Okay, thank you, Anupama. So we'll move to the final presentation.
Okay, thank you.
So our final presenter is Tamara Prabuddha Liyanage, and the paper ID is 136. And Tamara Prabuddha Liyanage is a fourth year undergraduate at Sri Lanka Institute of Information Technology, and he is following the BSc Honours in Information Technology degree program, specializing in interactive media. And the paper title is Chess ADC Automated AD Camp. Okay, Tamara, you can do your presentation. So I think if we have the recorded video, then we can play.
Hello everyone, I am Tamara Liyanage, an undergraduate at SLIIT, specializing in interactive media. I am here to present our research project, Chess ADC, an automated AD camp, on behalf of my team. These are my team members: our supervisor, Mr. Ishara Gamage, our co-supervisor, Mr. Tusitanjana Tilakaratna, and my fellow team members, Anuas Diulage, Uchika Deepta, and Malit Ishara. So the purpose of our research is to introduce a comprehensive framework to help someone who has any level of experience in chess to practice and develop their skills further. We call this framework Chess ADC, an automated AD cam, because it functions like an AD cam for a player. In other words, it is an assistant software dedicated for chess. Chess ADC can recognize a real chessboard using a web camera mounted to capture the top view of the chessboard. This feature allows to play a chess game on a real chessboard while getting the assistance from the software. Players can access Chess ADC interface from their smartphone. From that, players can get hints about the best moves they can make, and they can see the predicted moves of the opponent generated from the system. These hints can be accessed by the user only 3 times in a single match. This can train the players how to think in difficult situations and make better moves. Also, the system notifies the player when he or she has made a wrong move and helps to correct that move. This is the high-level system architecture diagram of Chess ADC. We are developing this software as a web application. Users can host a chess game using a PC. That PC will be the game host device. The camera which is used to capture the chessboard should be set up with the game host device. After the game is hosted, players can connect to the session through the web application using their smartphones. Inside of the system, we have several microservices dedicated to 2 specific tasks. The board setup service and the board tracking service use image processing and machine learning to detect the chessboard and recognize chess pieces. The next best move service is used to generate hints about the best moves for players in difficult situations. We use an open source chess engine called Stockfish to power this part of the system. The opponent prediction service is there to make predictions about the next move of the player. This service is powered by a machine learning model developed by us. Inside the model, we have 7 neural networks dedicated for several tasks. One of them is a convolutional LSTM neural network, and the other 6 are convolutional neural networks, also known as CNNs. The complete model can analyze the last 7 steps in an ongoing game and predict 3 possible moves that the player may take. We used data from Fix Games database to train this model. These are the accuracy levels we got from the move prediction model. Pawn 70.71%, Knight 54.52%, Bishop 42.73%, Rook 28.27%, Queen 23.96%, and King 47.77%. The model's accuracy increases as the movement range of the piece type decreases. In other words, a piece type that can move in a larger range in the board shows less accuracy than the ones with a smaller range. Based on the observations from this research, we can say that image processing and machine learning can be utilized to improve the experience of chess learners and also professional chess players. And we think that chess needs more software solutions like this with different approaches. Also, I have to mention that the hardware solutions we have used in this research can be improved further to have a better user experience. Thank you very much for listening to my presentation.
Okay, thank you, Tamara. So, anyone has any questions to ask from the Tamara?
So, why you need the image of the board?
Tamara, could you please switch on your video and then answer the questions?
Can you hear me?
Yeah.
Yes.
So, I mean now chess is using a standard notation. So if it is a computer-based one, it is in a database. So the exact position of the pieces are captured from that notation. So why you need a separate image processing process to get the position to get the position of the pieces? So it is already there.
So
our goal is to let two players play a chess game in a real chessboard. Then we have to capture the real chessboard to generate a PGN. So that's why we
even
have
in a real chessboard, you can put, if you need, a sensors, and then also capture the if it is not a computer. So you mean you think you are playing with so there are electronic version of chessboards which you can directly feed the position into the computer. So that facility is there. Why you are thinking about putting if that facility is there, getting hardware, getting the image and segmenting and getting the position?
Yes. It will be so if we take that path, it will be only limited for those chessboards with sensors. So what our goal was to support as many chessboard as we can. So we had to use image processing technology in this situation.
Okay.
Like, yeah.
Any questions? And also, I had the same question. So you have used CNN classifiers to identify, to find that chess squares, right? So then you can very easily, if you know the coordinates, and then you can at least it is actually it's a matrix, right? So you can very easily find those places. So I don't know why you have used a CNN classifier for the. Yes, that's the issue. Okay, any other questions? Okay, there's no more questions. So thank you, Tamara. So we'll now conclude the session. So thank you very much the presenters and also the participants. So we are going to conclude this session. So Kavinda, so this is over to you.
Thank you, Dr. Andil, and all the authors who presented. So next we have the lunch break. So after that, let's meet at 2 p.m. for the keynote after the lunch break. And stay safe.